let's take some time and contemplate the game of standard 5-letter Wordle that we have just created together. So in this game, just to show that it runs again, we have iterated right over all these guesses, and that's kind of a little bit of flourish. I mean, we don't really need that for the prototype to actually work. So I'll go ahead and I'll just unindent this, and I'll make my guess just back to one item, world. But let's take a moment and look at some of this code. I'm not very satisfied with all of this code right now. And the main points that I have concern are this status, right, equals 1, 0, and -1. And then this kind of disintermediation, this binding, right, of these arbitrary status numbers, right, to specific colors. Essentially what I need is more context in order to understand this. If I were to see this, right, in some library code or module code, I'd be like, what the heck is 1? What's 0 and what's -1? There's missing semantic meaning behind these things. And one way that you can kind of circumvent some missing semantic meaning is to, instead of using arbitrary numbers, you can use an enum, or an enumerable. So we'll go ahead and let's just see what that looks like. And what we can do, I can write a new class that inherits from enum. We'll say it's like a status class or a check class. You can call it whatever. I like to keep my enum names short since you do use the class name a fair bit. But instead of using things like 1, 0, and -1, I could write is the word is in the correct position, right? Or I could also write, let's see, the letter is in the word, or the letter is not in the word. And so what we get here is just a little bit more semantic meaning behind what these values could be. And so if I were to assign these values, the 1, -1, 0 really doesn't matter at this point. So I can use auto from enum to just assign automatic incremental values into my class here, or into my new rule. And I can actually go into my code and I can simply swap out 1 for a correct position, 0 for is in word, and -1 for not in word. And now when you look at this, I hope you think, okay, this is a little bit more straightforward. I've added some semantic meaning behind, right, these entries in this color mapping, and I don't need some magical number to figure out how to interpret some magical number in order to tell what the status of this given letter is. And I'll go ahead and swap this out here. All right. Okay, and we rerun the code and it still runs just as expected, as if we had those letters in there. But I'm still not fully satisfied with this rewrite. All I've done, I added a little bit more semantic meaning to what my variables are and what my program looks like, but I've added 4 lines of code. I didn't take away any code, I didn't shorten anything in this, and I think we can condense this a little bit. What's happening is I'm establishing that these 3 statuses exist, and then I'm mapping them to some other entity, some string that I format, and then I set. I don't think we really need this mapping. In fact, I think this mapping, right, having these labeled as variables in themselves isn't very helpful. I think at the very least this should be a comment, or there should be a comment right above all these ANSI escape sequences and it says see Wikipedia with a link, right, to a table that has all of these values. So how do we represent that? Well, we can actually understand that this enumerable actually does represent a mapping from some singleton into some value. And we can use that value as the value of our enumerable here. So of our member, I should say. So dark was not in Word. I can go ahead and not in Word can just be green, right? I can do the same thing with, or sorry, just be dark. And then I can do the same thing with green, right? This will be the correct position. And then I can do the last with yellow. And then I can do away with these named colors and things like that. Now we do need to change a little bit of code here. So I've gotten rid of setting those colors, gotten rid of 3 lines there. I no longer need this mapping since it's since now these values are directly related to their enumerable members. The only thing I need to change here is if I try and run this, right, we get color map is not defined. Well, the status object actually has, right, that string that I need to format, and I can just access it from the status itself by using .value. And when I do that, you see, I get the same output as I did before, except now I've removed about 6 lines of code from what I had when I initially defined my status. And this is not all about removing code. This is about removing levels, removing intermediation within my code, and making my mappings, right, my colors directly map into their represented types or the entity that I'm choosing to represent them. And so we can actually file this down even a little more, in my opinion. I don't know how many enumerables you all have seen in the wild, but seldom do I encounter the enum type with a value of a very long string, or any string really. Typically I see them mapped to integers, but that's not always the case. And I'm not about to change my code based on what I have seen or not seen in the wild, but I am about to change my code if I think I can reduce its complexity. I don't think it's very important for this correct position, right, to reference the entire ANSI escape sequence of a green background and a white foreground. I think this correct position should just reference the unique parts of what I want to enumerate. And in this case, everything here is redundant and repeated except for these 3 values. And so if I wanted to just have my enumerables refer to those 3 values, those 42 for green, it is 43 for yellow, and then 40 for dark, I can do that. And what this means is I'll need some other way attached to my enum in order to represent the actual conversion to the color. Now I could write a function that just takes the enum and then coerces it, right, to have this background color and then spits out maybe another formatted string, or maybe it takes the enum, the status itself, the status member, as well as a letter and colors it there. But what I'm going to do is actually attach a function onto this enum, and I'll call this color. It'll take self, and we can always change this, but it's going to take, it's also going to take some text. Now, if you haven't worked with enums a lot before, one of the fun things about an enums method is that it's actually not accessible, right? Or you don't access them through an instance of the class. If you'll notice how I use these enums, right, you access the class object itself, and then you access its member. In order to access a method of an enum, you access a member of the uninstantiated member. And so you get this really fun, if I just print self, right? So anytime I call color, I just print self, and I'm going to get rid of all my other prints, so that's the only thing I'm printing, just to demonstrate this. This color method is actually attached to every single member of my enum. I need to get rid of, or comment these out. Okay. And then it takes some text, right? I'll just give it a dummy argument. Okay. And so we print self, right? And you see that at the top here, status.correctPosition. This self refers to the member that called the method. And so what we can do, since correctPosition refers to the value 42, right, self.value, I can use this in a great way, right? You see 42 comes out. I can use this to actually perform my string formatting for me. So this would look something like I would return, and then I would put kind of my template right now for my escape sequences. I would put self.value in here, and then I would put, let's see, 1M, followed by the text, followed by another escape, and close that out. And we'll make this an F string so that it renders correctly. Let's go ahead and write that out. And you see when I put text and I pass text to the correct position, .color, it all comes out green. So what does this look like in the change to our code? Well, all we do is we drop that and we say status.color. Let's go ahead and print that out. Bam. Behaviorally, we are back where we started, but programmatically and functionally, we have removed a lot of redundancy within our code, and we have gotten rid of any of these redundant mappings, right? Status equals 1, -1, 0, and we have provided some semantic meaning behind our code such that when we go to look at this maybe a month from now or 2 months from now, we know exactly what each status refers to given a letter. And we've also added in a templated way to actually perform that coloring operation for display purposes. So this keeps the status and its ability to color linked, but we can treat them as separate entities. I can access this status, correct position, or is in Word, and use them in other parts of my code while still preserving that semantic meaning. So I'd say we have a fairly solid game of Wordle here. There's one more thing that I do want to explore a little bit with you all, and that is, in this loop, this kind of main body here, I have defined kind of my game engine. Now, it's a good question whether or not this game engine should be part of kind of the main script of the code here, or do I want to abstract this or attach it even to this enum, the status enum. And my reasoning for that being, if I were to have this be a module or something of that nature, do I want this code, this logic, living separately from the enum type that it's pretty deeply intertwined with? And do I want this code to be something that a user is supposed to implement or write on their own? My initial assumption is that I don't really want this code far away from all the statuses since it relies so heavily on those status codes. So what I'm going to do is I'll add a little bit more to this enum, and I will add a class method. And we can call this check, right? So check will take, the class, and it will take a guess, and it will take a unknown, right? And so we can go ahead and paste this all in here. And so we're just kind of restructuring things at this point just to see how they work out. Now, we have another decision to make. Since we've wrapped this into a function, should I, right, create some list here and append, right, the guest letter as well as its status into the list and then just return that whole list? Or do I just turn this into a generator and yield guest letter and status? These seem to be the two entities that I'll be needing, right? I need the guest letter to format it with the status. Now I could wrap this up in something like a name tuple, but whenever you come to the question of do I turn this into a generator or do I pre-compute everything, throw it on a list and return that entire list, if you're ever unsure, I would always say to err on the side of the generator, because if you do need to concretize it, if you do need access to a list of statuses and letters as tuples, you can very easily do that with the generator. Whereas if you return a list, right, you can't go back into a generator to maybe access a specific state of a letter and perform some computation before advancing to the rest of your letters if you want to short circuit something. And so what this would look like, I could simply just use my status checker here, and it takes a guess and an unknown word. Status.check, guess, right. Okay, and so we have this generator object. And if we wanted to concretize it, we could very easily throw it all into a list just by unpacking it so. And there we have each word, each letter in my guess, as well as its status, if it's in the word, if it's not in the word, or if it's in the correct position. And so, if I wanted to work with this, I could simply iterate and say for guess letter, comma status in here. Just to make sure it works, I like overprinting essentially while I'm working. Okay, that does seem to work. And then I can use that status to color my guess letter. And here we go. We'll uncomment these. And you see, I end up with my same Wordle output, except I've combined some of this logic into a larger entity that relies on itself. Now, because I am using this as a class method, this does mean I no longer need to refer to itself. I can use the class object for that. And we get the same output. And now we have a very strongly working program here that has kind of abstracted away some parts of logic while also exposing, right, very semantic and detailed values about how it works. Now, if I want to go ahead and make this even more into a full-fledged Wordle game, we can do that same thing as before for turn really in range 6 rounds in a Wordle. And we can do that. Here we go, and I'll just move this down into here. Okay, and we end up with all of these letters, all of these guesses. Now I could go through and remake that list and demonstrate that again, but I think we get the idea of how Wordle works and how we can represent it in some Python code.